basically in real time if you want. So now it's the time for the presentation by Paolo Saviano. Simon gave a very good introduction about him and his background before. And Paolo will talk about our RTC CDN, which is the whole infrastructure that powers our virtual event platform for ITF and Right Meetings, and the very same streaming service that you are using right now to watch this event, for instance, or your friends at home. So without further ado, please, Paolo, go ahead and thank you.
Okay. I was nervous, but okay. Do you hear me? Okay. Okay. Hello. I'm Paolo Saviano, a full stack engineer at Meetecho. Probably my name doesn't ring any bell to you, but maybe you may remember me from other presentation like how to build a working LED wall, okay, or how to lose belly fat by eating a lot of sweets, but still art. I don't want to talk about this. And how to start a tech presentation in a very cringe way, keeping your audience embarrassed in real time. So it's so funny just to break the ice for me. and be sure that all of you are awake after the lunch. Because it's not over. Today, I'm honored to present to you for the first and probably the last time how to build and deploy a multi-purpose real-time content delivery network with a Janus Server. And you got it, the fun is over. Okay, let's talk about serious things. Sorry for that. Deploy Janus at a large scale. Yes, it could be easy when you know what you are doing. It's easy when you know the use cases you are working with, so you have time to pick your plugins, choose the better way to handle them, handle the resource on them, and so on. But moving on a multi-purpose approach, we have to face a lot of challenges. How to combine different plugins, how to choose the right plugin in different use cases, how to handle users across all the plugin features, how to handle different kind of ingress and egress actors, and so on. So please, let me try to make things a bit clearer, talking about the most common use case you can stumble across when in large Janus infrastructures. First of all, we have the Atollo. I choose the name, so we have the tool is when we have hundreds of small sessions. Each session has a few participants. All of them are speaking users. And for example, if you are using the video room plugin, all the contexts are isolated. We can have multiple sessions at once. Is the use case used when we have many video calls between few people. We have to figure out a way to optimize the resources along servers and how to address users properly in the infrastructure. Another kind of scenario is the big island, where when many users are in the same session, all of them are potential speakers, so they can speak at the same time, all of them, and the topology can change depending on which kind of plugins are we using. In an audio-only context, for example, this is the way Twitter developed the Spaces feature as they presented in the last JanusCon. We can spread the users across a set of audio bridges. Each audio bridge serves the user in its control and provides the mixed audio to the other audio bridge. The other audio bridge will see the content as an RTP participant on their side. If you want to scale, you have to add another instance for an audio bridge and address user on this. If we want to put video in place, we have to change. We can imagine to have a media stack composed by a video room and a streaming plugin per user. The user publishes its media into the video room, and the video room will forward through RTP forwarding to the other users' streaming nodes. So we can scale, creating an effective media mesh, and we can scale adding a new stack per user. Last scenario is the archipelago, when we have a session with few participant speakers and a large amount of viewers. We have a main island with a few participant speakers. It could be composed through an audio bridge, a video room, or both. And viewers are partitioned along the multiple streaming nodes. In this example, our main island is going to use both audio bridge and video room. Active participants' media are forwarded to the streaming endpoint, the mixed audio, and an RTP leg for each video. Passive users are connected to the streaming, only to the streaming nodes. So if they want to get the floor, we have to provide a way to promote them, creating a connection to the main island. Those are use case, simplest use case. We can combine them, we can change the plugins. It's just to have an overview of the classic infrastructures. Okay. Take a breath. Okay. Let's define a few requirements that identify what multi-purpose means for us. First of all, clients should be unaware of technical details. We don't want specific implementation on client side for different plugins. So we'd like to have a set of common requests to fulfill similar requests on different plugins. Because clients should be unaware of which topology they are using or how the topology is composed and so on. For example, if a user wants to subscribe to an audio feed, he should have a set of commands without caring if he's talking to a streaming or an audio bridge or a video room and so on. Then we'd like the different kinds of resources should be managed commonly. We need a way to connect plugins, and each plugin should provide a sort of aggregated status expressed through a specific syntax and with a protocol to update any status changes into the infrastructure. Lastly, what we need is what we want to get. So we need an overlay network that maps different nodes, and an orchestrator should be able to build that network in a smart way. Okay, so we have a lot of things to do. First of all, we need a superset of commands to hide differences. And we can rely on Janus. Janus is a JavaScript SDK for the Janus API we developed. I won't spend more words on Janus because Alessandro Top in an upcoming presentation will explain the library much better than I could. I want just that you know that through Janus we can build different kind of nodes, wrapping different kind of plugins. Those are two examples. We can have a sort of audio video room that offers an opaque client API. The node should be able to forward RTP to other nodes, and it can act as an ingress or egress for our network. Obviously, we can extend. Or maybe we can have a streaming-only node, mainly because streaming offers better performances for large number of users. It should act like as an egress for the RT-CDN, and it should be capable of receiving RTP streams. Then we have a way to identify the status and provide a set of tools to collect and serve this status to the other components. Mainly, we can find three different kinds of data that compose the status. The node presentation. Those are information about the node identity and how the network could reach the node, like its address, port, and its type. We can add a few hardware information like the CPU usage or the memory usage, and we have a wrapping index called weight that represents the effort on a node in a specific instant. This could be the number of peer connection or the number of active mixing and so on. And finally, we have to add a few specific plugin-specific information. A video room should write its context, the codec, the max publishers, the list of handlers, publishers, active forwarders, as well as the streaming should provide the number of mount points of the list of active viewers currently subscribed. Okay, where this data goes? Into an etcd service. etcd is a distributed key store that provides several interesting features. Mainly, we have a leasing time. A key is valid as long as its owner refreshes the key itself. We have the capability to do transactional operation in order to grant sequential writing consistency. The sequential consistency in a TCD that allows to have that grants to us, that all the readings are ordered, and then we can lister for prefixes without knowing the exact key we have to read. Last three feature, the feature I just mentioned, allow us to have a sort of incremental data notification. The reader that I hadn't introduced yet waits for a particular key that we can call signature key for the prefix JN. Eventually, the writer writes its key, writing its type, var, then its ID, node 1, and a set of keywords. Lastly, he will write the signature key composed by the JN, its ID, and var. Only after the last writing, the reader hits a new key, it's able to parse the key, retrieving the brand new node 1 and var information, and can look directly for the key he had to read. Finally, we need an entity responsible for the orchestration. It's the broker. The broker is a service written in Go. We authored. It implements a set of node wrappers. What does it mean? With Janode, you can create the node, and you have to add the related module into the broker code. Each node wrapper instance is related to a real node instance. And when the node writes its presentation data on the etcd, it will a new instance for the module for the wrapper is instantiated inside the broker. All the wrappers are stored into fast searchable structures like heap, hash map, everything that we need. Each wrapper is responsible for its status and its API. Linked wrappers builds a virtual map, and map can change into the broker only on etcd updates, and the change can trigger optionally an action. This is a quick example. A new mount point is available for the session XYZ. The map update detected that mount point should be fed. It's not fed yet, so we should feed it, and then it can take an action informing the source to provide a new forwarding for that mount point. Few more info, there is no local data persistence. It accepts functional requests through an HTTP API. Each request triggers a decision based on custom policies. The decision is followed up optionally by an action, and the broker is the only entity that knows the overall topology. A request can be get the room XYZ feeds. Through the map, the broker knows where is the room, if there are enough streamings attached, and eventually it can trigger request to a node to allocate a new mount point. Or create a room, what kind of room, on which node, allocate a new room. Okay, let's summarize this. Nodes provides their status in a write-only mode to the etcd. The broker is aware by existing nodes through a read-only etcd change, updates the map, and it can take actions. When the map is stable, a new ingoing request through the API can trigger an action, change the status, and so this is the circle of life. Okay. Okay, as you have seen, sometimes things can get worse. Maybe science doesn't work properly. So we have a few different mechanisms to achieve a full tolerance procedure. If a client detects, if the client loses the connection with a node, initially he can try to reconnect on the same node. If the attempt succeeded, we can blame the network and go ahead. If not, eventually the lease time will expire. So the broker detects the failure, changes its map, and can trigger, for example, spawn a new node for the orphan streamings. Same happens if it's the broker, the first one to detect the failure. The lease time expires, the broker makes its decision and informs the new client about a new node. We can extend this infrastructure. For example, we can add a mixing tool to merge all the media, audio and video, and provide and feed an RTMP endpoint. This is the way we provide the mixing in our sessions. This node has a custom API to enable to toggle contributes, change layout, and so on. And it should be capable of receiving RTP streams and inform the etcd layer about its status. Same if we want, if we had to add some AI modules, maybe we have to, we want to make some real-time processing for live transcription or live media enrichment, putting HAT on our users. We are capable of, the node should be capable of or sending or receiving or both the RTP streams. And I won't go further in this, spoiler, because tomorrow Antonio Bevilacqua will introduce how we are moving our steps in this, into this field. There was a lot of chat about this, but this is a real thing. We are already put this in news. We are the official provider for remote participation to few conferences like the ITF. During an ITF week, we have almost 200 sessions per week. Up to 10 are simultaneous. We have up to 1,000 unique participants that can join at the same time to multiple sessions. We have to handle both on-site and remote users and enrich the experience through live transcription, media mixing, and a few other things. We can achieve all of this. We achieved all of this mixing the atoll and the archipelago setup. There is a bit, and brag this, we do this with satisfaction by our customers. But how we can do this? Initially, we wrapped each of the nodes, each of the elements I presented to you in a Docker container. Through a Docker container, we can achieve the replicability, of these nodes and have fault tolerance, scalability, and so on. And several services, different services, are spread across different servers through the Docker Swarm engine. Then we had a set of application microservices, for example, an gatekeeper that allows users to be authorized inside the whole infrastructure with a few different login methods like token, OpenID connection with IETF. We have a user backend that handles the in-session request and handles the first level of signaling, managing the tools like the media, but also the Q&A, chat, and so on. admin backend, slides processor, we have the recordings, anything we need, because all the applications, all the application layer is completely orthogonal to the MediaRT CDN. Lastly, we have to provide a set of clients that act like sources for the RTCDN, both on-site client app, the remote on-site app. We have we get the static feeds from the room, like camera, like the camera we have here, or we get the mixed audio from the mixing board inside the venue. On the other side of the RTCDN, this kind of these streams are cherry-picked by different application. We have a monitoring apps to handle camera feeds, so we can control and take in just those feeds. We have on-site companions like a screen share tool to show in the venue, in the room, what's happening on site, a video wall with all the remote participants, an external MP3 converter, and the mixing I mentioned, and so on. Okay, obviously we had several issues that come up. First one, and I'd like to share that with you, those with you. We have an issue on the called the publishing audio delay. When does it mean when the topology assessment takes too long? Okay, what does it mean? If you remember this slide, I said that a passive user is attached only to the streaming, and it needs to be promoted. It should establish a new connection with the main island. For quick answer, like, are you hearing us? Yes. We totally lost the answer because the connections takes too long and the audio is get lost. In a first moment, we have the idea to connect all the using to the audio bridge and mute the audio on client side, turning off the audio encoder on the clients for cut off the bandwidth usage and to grant privacy. Unfortunately, this wasn't enough because the users, muted users, wait on the mixing audio, and the audio bridge wasn't capable of support so many users. Luckily, we have the we changed the audio bridge code, adding an audio suspended mode. Suspended users won't wait on the effective effort on audio bridge because they are explicit. The plugin keeps these contributes outside the mixing loop. Another kind of issue is the session opening burst with hundreds of users in a waiting room. When the room opens, the users can overcome the topology elasticity. So we have to add a few parameters like warm-up options that give us a bit of more space and allocate a bit more resources that we need, so we have the time to scale properly. And on the other side, we have the scale down issue. Abandoning user can cause sparse graph. So we have to reorganize the topology when the usage is below a threshold. Okay, it was faster than in my tries. Next steps, we are already working on this, and other things are on our roadmap. We would like to move some ad hoc code in microservices or libraries, like the monitoring and logging, a client-side SDK. We'd like to make the decision policies pluggable so we can change in the broker at runtime. And we'd like that the decision should be made not only on technical details, but also on something that the user has, as its geographical position, the device. Obviously, we are moving on. We'd like to add more AI modules. And finally, we have to add the multi-stream on this. Okay, this was a long run. Thank you for listening. And sorry for bothering you so long. And feel free, don't listen over, and feel free to say anything you have in mind.
Thank you, Paolo. And I really hope they will ask questions. Ask no questions is not a viable.
It's rude. Don't listen to it.
Okay, we have Damien.
You gave a real-world example at the beginning of a particular scale you did with IETF. What is? Do you have other examples of these topologies doing million-scale type stuff? Or?
We are working with a few customers on this. I don't know if there is some sort of NDA, but yes, we have another kind of use. Another conference is the RIPE conferences that work is the same. There is a slight difference, but on applicative level, the infrastructure is quite the same. And
I don't know. There may be snipers around, so maybe.
sorry for that, but
yeah, but yeah, the answer is yes. We do have
yeah.
some big players using some sort of.
But it's the same architecture.
Yeah.
It was just you were talking about all these architectures and said 1,000 simultaneous.
Other questions for Paolo? Oh, I see Saul over there.
Hola.
Hola.
I've got a question about your use of etcd. I'm not like directly super familiar, but I think some of the like the way you use it also kind of as a registry has a certain overlap with console. Did you consider making it part of the stack?
Yes, this kind of architecture is was developed a few years ago, and when we figured out how to handle this, we take in consideration console as a Kafka. It's pretty much the same, but for etcd, we found the few features that make the road to the what we have in mind more straight. So we
Like simpler.
bet on that, bet on it.
Makes sense.
Any more questions or? No? Okay, then thank you, Paolo. Thanks again.
Thank you all.